Alright, in problem number 1 we have these two overlapping circles, and we're told that they're congruent circles and that their centers are at A and B, and they share a radius AB which measures 3 centimeters. Alright, so we know that this length from A to B is 3 centimeters, and we're asked to find the perimeter of the figure. So let's take a look at what we got here. I'm actually going to draw in the rest of these two circles. Okay, so I'm going to sort of draw a dashed line here, try to make it curved so that you can see what we're dealing with. Alright, it's a little easier to see this way. So you can see now there's circle B, and the edge of circle B passes through the center of circle A. Alright, and let's do the same thing for circle A. So if I draw in a curve from the top here to B and then curve it around a little more, essentially completing circle A, then you can see, okay, here's circle A, and the edge of circle A intersects the center of circle B. Alright, so now you can see what we're talking about when it says that they share a radius. Okay, so their centers are connected by this radius AB. Alright, and the edge of one circle intersects the center of the other. So that gives us a sense of how the overlap is working. Alright, so we're asked to find the perimeter, and if we were asked, if we, we can find the perimeter of a circle, or just the circumference of a circle. Okay, so circumference is equal to what? It's pi times the diameter, or 2 pi times the radius. Alright? But we don't have a complete circle. We have a portion of circle A is included in the perimeter of the figure, and we have a portion of circle B that's included in the figure. Okay? So we need to figure out how much of the circumference of those circles is actually included in the figure here. Alright? So let's, I'm actually going to draw some more on this picture, because you can see that we can draw in a radius anywhere on the circle, and it's going to be 3 centimeters, right? Because it's a circle, and that's just the definition of a circle. It's the set of the points that are the same distance from a center point. Okay, so so if I draw on a line here from A, let's just call this C, and this D, okay, and I'm referring to this point here and this point up here. So I can actually draw a radius from the center A out to this point C, where the two circles intersect, right? And that's also a radius of A. So I'm going to draw that in, try to make it reasonably straight. Alright, so you can see there's a radius there. And I could draw the same, another radius here from the center B to point C. Okay? And we know that both of those radiuses are 3 centimeters, radii, right? Alright, 3 centimeters, okay? And the same way down here, I could draw a radius from B to D, and that would also be 3 centimeters. And I could draw a radius here from A to D, and that would also be 3 centimeters, okay? So look what we've got here. We have a triangle, and it's a triangle with sides that are all 3 centimeters. So what do we call a triangle that has all, where all the sides are the same length? Well, you probably remember that we call that an equilateral triangle, right? And an equilateral triangle just has sides that are all the same length, but it also has, let me finish my color here, it also has angles that are all the same, right? So this angle and this angle and this angle will all be the same, as well as this angle and this angle, and this angle. Okay, and what's the measure of that angle? Well, you know there's 180 degrees in the triangle, and if we divide 180 by 3, we get 60 degrees, right? So each one of these angles is 60 degrees. Alright. 60 degrees, 60 degrees, and 60 degrees. Okay. So, let me go back up here, grab a black pen. So you can see the angle from AC to AD, this angle here, ACD, is actually 120 degrees. And you know that there are 360 degrees in a circle, so if we take that 360 degrees and we subtract 60 plus 60, which is 120, we end up with 240 degrees. So this angle outside here is actually 240 degrees. And the same way over here, the angle out here is 240 degrees. Alright? So now you can take a look, you can see the proportion here of how much of this arc is swept out compared to the whole circle, right? So, so essentially we've got 240 out of 200, oops, not 200, 360 degrees. Alright, that's the arc swept out by this angle, this 240 degree angle. That's equal to 2/3. Alright, so 2/3 of this of the total circumference of circle A is included in the figure. Okay, you see that? Because 2/3 of the 360 degrees are included in that circle. They're included in the figure. Okay. In the same way over here, we have 240 of the 360 degrees are included in the figure. Okay, because over here, this 120 degrees here and this 120 degrees are inside the outer perimeter of the circle, so we don't really care about that. We only care about the portion that is outside. So we have essentially 2/3 of a circumference of a circle here, and we have 2/3 of a circumference of a circle over here. Alright? And we've got so we have two of them. So we have 2/3 of the circumference of a circle, which is 2 pi r, and r in this case is 3. Alright? And we've got two of them, right? Because we've got this arc, which is 2/3 of a circle, and this arc, which is 2/3 of a circle. Okay? So 2 times 2/3 of a full circle. Alright? And we can compute that out. You can see that this 3 and this 3 will cancel, it'll just make 1. And then we have 2 times 2 times 2, which is 8. And that times pi. So that's the answer. 8 pi centimeters is the perimeter of this figure. Or if you wanted to multiply it out, I think it comes out to be something like 25.13 centimeters. Okay. Alright, so 8 pi centimeters is the perimeter of this figure.